Welcome back, dear children. Now we will move to the numericals. Okay. So please take page number 11 in your textbook. Page number 11. Question number 1. No need to copy the question. You can put the page number and question number. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. Okay. So, what all things are given here? In the question it is given that the moment of force of 10 Newton. Is 10 Newton the moment of force? Is it? No. 10 Newton means it is just force. Okay, so here many questions will be there which will confuse you. So, first thing is check the unit. With the unit, you have to identify the physical quantity. Since it is written as 10 Newton, what will be the quantity? That will be force. Okay. Even though it is written as moment of force is 10 Newton, it is not moment of force, it is force. Because 10 Newton, Newton is the unit of force. What is the unit for moment of force? It is Newton meter. So, 5 Newton meter is the moment of force. Torque or moment of force is 5 Newton meter. Okay, so we go have force as well as torque or moment of force with us. And what should we calculate here? Calculate the distance of the point O from the line of action of the force. That is, you are asked to calculate the distance. What is our equation? Torque or moment of force is equal to force into perpendicular distance. And from here, what is distance? Distance will be equal to, I keep distance here. So, where will this F go? Moment of force is equal to F into distance. So, if you have such an equation, just keep the other quantities there itself. Okay. So, here I need distance. I'll keep distance here itself. Let the moment of force remain there. I have to change force. Since force is in the numerator, when it moves across the equal to sign, what happens? It goes to the denominator. So, distance is equal to moment of force divided by force. How much is our moment of force? Moment of force is 5. Force is 10. 5 divided by 10, which is equal to 0.5. Then it is distance. Here it is in Newton meter. So the answer will be 0.5 meter. Now question number 2. A nut is opened by a wrench of length 10 centimeter. That means the distance, isn't it? Length is distance. So distance is equal to 10 centimeter. But one issue is there. What is that? 10 centimeter. We need it in meter. How to convert centimeter to meter? Smaller to bigger means you have to divide. So 1 meter is 100 centimeters. So you have to divide with 100. So how much will be your answer? It will be 0.1 meter. Okay. So that is the next thing what you have to keep in mind. Distance is given as 10 centimeter, which is equal to 0.1 meter. Now, if the least force required is 5 Newton, that means F is given as 5 Newton. You are asked to calculate the moment of force needed to turn the nut. So, moment of force, I'll write it as torque. Okay. Moment of force is equal to force into distance. Force is 5. Distance is 0.1. 5 into 0.1 is 0.5. Then, it is torque. Newton into meter, which is equal to Newton meter. So, it's a simple question, only direct substitution. But where will you go wrong? You will just give 10 centimeter and multiply, which will be wrong. Here you have to convert it into SI system. Now question number 3. a wheel of diameter 2 meter. Okay. So this is the wheel. Its diameter is given as how much? 2 meter. Okay. So a wheel of diameter 2 meter is shown in the figure with axle at O. So axle means it's the point where this body rotates. Okay. Axle. The body rotates about the axle. Then a force F is equal to 2 Newton is applied at B. You can see that this force of 2 Newton acts on B in the direction shown in the figure. Okay. So these are the things given in the question. That is, a force of 2 Newton acts on the point B. Then the axis of rotation is O. The total diameter of this wheel is 2 meter. Now we will check what all things we have to calculate here. First one, calculate the moment of force about the center O. Okay. So you are asked to calculate the moment of force or torque about O. So what is our equation to calculate torque? Torque is force into perpendicular distance. Okay. So what is the force acting here? It is 2 Newton. Now the next one is the perpendicular distance. Which distance should we consider? Should I take it as 2 meter? No. Distance means it should be the distance between the axis of rotation and point of application of force. We are asked to calculate the torque about the point O. So I need the distance between O and the point where the force is exerted. So this distance is required. The total diameter of the circle is 2 meters. So what is the radius? This is actually the radius, isn't it? So how much is the radius? It is 1 meter. So the torque will be 2 Newton meter. Did you understand how we got this answer? Torque or moment of force means it is force into perpendicular distance. That distance means it should be the distance between point of application of force and axis of rotation. So here the point of application of force, or where we are considering, that point is needed. Okay. So here O is, we are asked to calculate the moment of force about the point O. So the distance from O to B should be considered, which is 1 meter. Because diameter of this wheel is 2 meter, we need just the radius. Now, here in your textbook, the direction of rotation is also given. Force is acting in this direction. If the force is acting in this direction, means rotation will take place like this, isn't it? So if it rotates like this, this is which direction? It is clockwise direction. So if it is asked, then only you have to mention whether it is in clockwise or anti-clockwise direction. Now, question number 2. Moment of force about the point A. So here the point is given as A. So you have to calculate the torque about the point A. So what will be the torque about the point A? Same equation. It is force into distance. Force is same 2. But what about the distance? Distance means it should be always between the point which we consider as well as point of application of force. So we have to consider this much distance. So how much is that? It is 2, which is equal to 4 Newton meter. So you have to check the point. In the first case, it is asked to calculate the torque about the point O. So you should measure the distance only till O. In the second question, it was given as point A. So you have to consider the distance till point A. So the answer will be 4 Newton meter. And here also, since the force is acting in this direction, the rotation or the turning effect will be in the clockwise direction. Clear? Now we will move to question number 4. The diagram shows two forces, F1 is equal to 5 Newton and F2 is equal to 3 Newton, acting at points A and B of a road pivoted at a point O, such that OA is equal to 2 meter and OB is equal to 4 meter. So what all things are mentioned in the question? Same thing is seen in the diagram. Okay. So we are having a road AB. It is pivoted at the point O. Now we have two forces F1 and F2. F1 is 5 Newton and F2 is 3 Newton. Now this distance between A and O is 2 meter and between O and B is 4 meter. These are the things given. Now we will check what all things we have to calculate. Okay. So first one, calculate the moment of force F1 about O. So we have to calculate the moment of force F1 at O. That means what is the moment of force produced by the force F1 at O. Okay. So moment at O due to F1. Okay. So what is the moment at O due to F1? So what is the equation for moment of force? Moment of force is equal to force into distance, isn't it? So how much is the force F1? Force is 5 Newton. Now the distance, already I told you, when you are finding the distance, it should be the distance between point of application of force and the pivot. So here it is 2 meter. So 5 into 2, which is equal to 10 Newton meter. Now second question, and what about the direction? In which direction, due to the moment, due to the force F1, a moment of force is produced, and in which direction will this moment of force try to turn this object? In this direction. That means it acts in the anti-clockwise direction. Okay. So it acts in the anti-clockwise direction. This is question number 1. Now question number 2. Moment of force F2 about O. So what is the moment of force at O due to the force F2? So here also force into distance. Force is 5. Then distance here, force is 3 Newton. 3 Newton is the force here. Then the distance is 4. So here it is 3 into 4, which is equal to 12 Newton meter. 12 Newton meter is the moment at O due to the force F2. And what about the direction? In which direction will the body move due to this force? This is the direction. That means it moves in the clockwise direction. Okay. So here it tends to move. This moment of force tends to move the body in the clockwise direction. Okay. Now we will move to third one. So what is the third one? Calculate the total moment of the two forces. So what will be the total moment or the resultant? So when you are asked to calculate the total moment or the resultant moment, what you have to check is in which direction are the forces act. Okay. So if the forces are acting in the same direction, you have to add it. If they act in the opposite direction, you have to subtract. So here we are having two forces. One force is acting in the anti-clockwise direction, whereas the other one is acting in the clockwise direction. So what will be the total moment? Total moment will be the difference between the two. Okay. Since one is in the anti-clockwise direction and the other is in the clockwise direction, total moment will be 12 minus 10, which is equal to 2 Newton meter. Okay. And in which direction is it moving? 12 is in the clockwise direction. So the total moment will be in the clockwise direction. Okay, so when you are asked to calculate the resultant, always find the direction or in which the moments are acting. If the moments, both the moments are in the clockwise direction, just add it. If both are in the anti-clockwise direction, then also you can add it. But if one is in the clockwise direction and the other is in the anti-clockwise direction, just subtract it. Okay, so is it clear? Now we will move to question number 5. Two forces, each of magnitude 10 Newton. Okay, we are having two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at the ends A and B. So this force is acting in the upward direction, whereas this one is acting in the downward direction. Of a and B of a uniform road of length 4 meter. So the total length of the road from A to B, it is 4 meter, which is pivoted at its midpoint O. The pivot is at O. Determine the magnitude of the resultant moment of the forces about the pivot O. So here also you are asked to calculate the resultant moment. So what should you do? First calculate the moment produced due to the force acting at A. Then the moment due to the force acting at B. Then check the direction. If both are in the same direction, add it. If they are in the different direction, subtract it. So what should you write first? Moment due to force at A. Okay. Moment due to force at A is equal to, what is the force here? It is, anyway, moment of force means only one. The equation is there, that is force into distance. So 10 is the force into distance. So should we take the distance as 4 meter? No, distance will be between A and O, because A is the point where force is exerted, O is the pivot. So the entire length is 4 meters. So what will be this distance? It will be 2 meter. So 10 into 2, which is equal to 20 Newton meter. And in which direction is the body moving, or in which direction will the road turn here? In this direction means it is in the clockwise direction. Okay. If the resultant is asked, you have to write the direction. Then only you will understand whether it is in the clockwise direction. Sorry, whether you have to add it or subtract it. Now, next one, moment due to force at B. So, what is the moment produced due to the force at B? Here also the force is 10 Newton, distance is 2. So 10 into 2, which is equal to 20 Newton meter. And what about the direction? Here also it is acting in the clockwise direction, isn't it? So which is, I think you know which is clockwise and which is anti-clockwise. In this direction will be the needle of the clock moving. So this is considered as, this direction will be considered as clockwise, whereas this one is anti-clockwise. Okay. Now, here both are in clockwise direction. So what will be the resultant? Since both are in clockwise direction, resultant will be the sum of two moments. So 20 plus 20, which is equal to 40 Newton meter. Okay. So the answer is 40 Newton meter.